In this video, we'll solve some word problems on equations of straight lines. Here's the first one. The length L in centimeters of a copper rod is a linear function, this is the important word, is a linear function of its temperature in Celsius. In an experiment, if L equals to this when C equals to 20 and L equals to this when C equals to 110, express L in terms of C. Now pause the video. Think about this. Try this on your own. Okay, let's break this down. This is a linear function, which means we'll get the equation of a straight line. Now, these points will be on the line. And what are these points? If we put C on x-axis as input and L on y-axis as output, the points are 20, 124.942 and 110, 125.134. Now, if we graph these values, this is what the line would look like. It looks like a flat line, it's almost horizontal, but the slope is not 0. If the slope was 0, the value wouldn't have changed, but the value changes. The value moves up from 124 point something to 125 point something. So the value is increasing at a very slow pace. Alright, let's form the equation now. How do we form the equation? We have these 2 points. We can use the 2-point form. That's y minus y1 by x minus x1 equals to y2 minus y1 by x2 minus x1. We'll plug in these points. Y minus 124.942, this y coordinate, by x minus 20 equals to the difference of the y coordinates upon the difference of the x coordinates. So the denominator is 90. This value is 0.192. The difference is only of 0.192. This remains the same, y minus 124.942 by x minus 20. Now let's cross multiply. This is 90y minus 90 times this. This is going to be 1124.78 equals to 0.192x minus 20 times this. That's 3.84. Now we can rearrange and divide by 90. We'll get y equals to 124.67711 plus 0.00213x. This equation says that at c equals to 0, the y-intercept is 124.677. So at 0 degrees Celsius, the length is 124.67711. And when you increase the temperature, the copper length expands. It expands at the rate of 0.00213 centimeters per degree Celsius. So after 100 degrees, it expands to 0.213 centimeters, which is roughly 2 millimeters. So this is the equation of this line. If you have to express L in terms of C, we can say that L, the length in centimeters, is equal to 124.67711 plus 0.00213 times C, which is the temperature in Celsius. Let's solve one more. The owner of a milk store finds that he can sell 980 liters of milk each week at rupees 14 per liter and 1220 liters of milk each week at rupees 16 per liter. Assuming a linear relationship between selling price and demand, how many liters could he sell weekly at rupees 17 per liter? Pause the video, think about it. Okay, so when the rate was 14 per liter, the owner sold 980 liters. When he charged 16, he was able to sell more, that's 1220. So if he's selling at rupees 17 per liter and if the relationship is linear, this means the owner would be able to sell more than 1220 liters. Let's draw the graph. X-axis and y-axis. On x-axis, let's put the selling price, and on y-axis, let's put the demand. And because these values are very large, let's scale the y-axis. Let's say we measure the demand in hundreds. So this will be our graph. Now notice we have 3 points here. The first point is 14,9.8. This means at 14 rupees per liter, we're able to sell 980 liters. Multiply this by 100, we get 980. This next point is 16,12.2. This means at rupees 16 per liter, we're able to sell 1220 liters. Now on this line, because we're assuming this is a linear relationship, on this line, we need to figure out what are the y coordinates for the point which has the x coordinate as 17. So if we draw the line x equals to 17 and see where it intersects this line at 13.4. This means that when you're selling at rupees 17 per liter, you're able to sell 13.4 times 100, that's 1340 liters. So at rupees 17 per liter, he'll be able to sell 1340 liters. So this is how we can solve it using the graph by plotting the equation of this line. But if we're not able to plot the graph accurately, we can still use the equation and plug the value of x equals to 17 to get the output 1340. Let's see how. We have these 2 points. Using both the points, we can find the equation. So equation of a line in 2-point form is this: y minus y1 by x minus x1 equals to y2 minus y1 by x2 minus x1. Plugging these 2 points, we have y minus 9.8 by x minus 14 equals to 12.2 minus 9.8 by 16 minus 14. This is the equation. We can simplify this. This becomes 2 times y minus 9.8 equals to 2.4. This difference is 2.4. 2.2 plus 0.2 times x minus 14. 2 cancels out with 2.4. This is y minus 9.8 equals to 1.2 times x minus 14. This becomes y minus 9.8 equals to 1.2x minus 12 times 14 is 168. So 1.2 times 14 is 16.8. So this becomes y equals to 1.2x, and then the difference of 16.8 and 9.8, that's 7. So that's y equals to 1.2x minus 7. And this is the equation of this line. We have assumed a linear relationship. Now we need to find the output at x equals to 17. So let's plug in x as 17. We get y equals to 1.2 times 17 minus 7. 12 times 17 is 204. So 1.2 times 17, that's 20.4. Y equals to 20.4 minus 7, that's 13.4. So the point is 17, 13.4. Now how many liters? To multiply this by 100, we get 1340 liters.